we will see what are irrational numbers, and we will see examples of irrational numbers. So the word irrational, what does it mean? Irrational, that means which is not rational. And as we know from our earlier knowledge that the square of number 2, 3, 4 will be 4, 9, 16. And so if we want to take the square root of 4, 9 and 16, for example, so it will become like under root 4, that will be 2, and then under root 9 is equal to 3, and then under root 16 is equal to 4. So what does this indicate? That we have under root of or square root of 4, 9 and 16 is a perfect value, and that is why this number perfect value, these number like 9, 16, 4, 25, they are called perfect square. Because their square root is giving us the perfect value or the accurate value. But imagine if we want to calculate the square root of 3 or square root of 2 or square root of number 5, then we do not get perfect value. So if we either by the long method of calculating square root or by the use of calculator, if we try to do it, what do we get? We get only an approximate value. So under root 2 is equal to 1.414. Now this is an approximate value. This is not a perfect value, and it is not. But on a number line, we can see that this is 0 and this is extending here. So, and this is 1 and this is 2. 1 and 2. And so somewhere here will be 1.41. So somewhere here this will be under root 2, which will be like 1.4 and 1.5 in between this. Similarly, if we want to take under root 3, we will not get a perfect value. So these numbers where we do not get perfect value and we only get approximate value are called irrational number. They are called irrational numbers. Irrational numbers. So we do not have, they cannot be represented either in decimal form or in the fraction form by a perfect number. They are only represented by approximate values. We always get only approximate value. The other example of such irrational number is under root 3. Cube root 3. Cube root of 5. Whereas cube root of 27 is 3. So this is perfect value, and that is why 27 is called perfect cube. But other values like 26, 28, 29, if we want to take their cube root, they will all result in irrational number. Now, irrational number can be represented on the number line and uh, by a unique point, and and this can be done only by geometrical process, which we will learn later, that by a geometrical process we can represent irrational number on the number line by a unique point. So as such, all irrational number can be represented on number line as unique point as unique point. So we should remember this, that as such all these irrational number cannot be written by their accurate value either in decimal form or in the fraction form, but they can be represented by geometrical process, which we will learn later, as unique point on number line. Another commonly used irrational number is pi. And what is pi? Pi is a ratio between circumference of a circle to its diameter, and then diameter of the circle and this ratio is represented in an approximate value like 22/7, and in decimal form also it is represented as 3.14. But none of them, either 22/7 or 3.14, is the perfect value of pi. And in fact, there are a lot of lot of work done in mathematics trying to give more and more accurate value of pi, but we can never represent the accurate value of pi in either number form or in fraction form. But geometrically we know that any circle, the ratio between, we know the circumference and we know the diameter of the circle, and the ratio between the two is pi. So summarizing what we have learnt irrational number. These are numbers which are like square root of 2, square root of 3, square root of 5, which we have written here, and they cannot be represented by perfect value. Only approximate value can be written. For example, for under root 2 it is 1.414. Similarly, the cube root of any number other than the perfect cube are also perfect cube. So we should keep in mind perfect cube. They are also irrational number. But all irrational number can be represented by unique point on number line, and this can be done only by geometrical process, which we will learn later. Thank you.